Okay, hello, I'm Ryan Herman, and I am the rep with Fisher & Paykel Health. And we are the manufacturers of the OptiFlow system, as well as the heated humidifiers that are used on your ventilators, your BiPAP masks, and your humidified circuits. I'm here today to give you an in-service and answer any questions you might have about this OptiFlow. Have you seen this before? Mm-hmm. Okay. So OptiFlow is our brand name. Generically, it's often called humidified nasal high flow therapy. And one of the things that separates OptiFlow from traditional oxygen therapies is that we can actually turn the flow up to 60 liters per minute. And therefore, we can meet the inspiratory demands of the patient. When we meet or exceed the inspiratory demands of the patient, then there's no need for the patient to entrain room air in order to meet their own demands. So it's minimized. Therefore, the oxygen concentration that you're delivering is more accurate than, let's say, for example, you're just running a 4 liter per minute cannula on a patient at 100% O2. They're not really getting 100% O2 because they're entraining room air in and diluting it out. Mm-hmm. Okay. So the other benefit of that really high flow is that it's going to generate some low levels of positive pressure. And that means that we're going to actually reduce dyspnea. We're going to give them a little bit of respiratory support that cannot happen with mask oxygens. Okay. The other thing about OptiFlow is that we're actually going to be conditioning the medical gases that are coming into it by using our heated humidification technology. I'm going to try to move this so that you can see it here, but when you power on this humidifier, it always defaults to this top mode here. If you were able to see that really clearly, it looks like an intubated patient. It's called the invasive mode or invasive setting. That's going to condition the gas to 37 degrees Celsius, 100% relative humidity. That's what we call optimal humidity. And that's where we want it. Even though we consider OptiFlow a non-invasive therapy, we want to deliver the gas at body temperature saturated gas. That will ensure three things. Number one, that we're not stripping any moisture in the airway mucosa. And number two, that we're maintaining full airway patency. And number three, that we're optimizing the patient's secretion clearance by optimizing their mucociliary transport system. Okay. So, I mentioned before that we can deliver up to 60 liters per minute. So, with this flow meter, we can adjust our flow in liters per minute. Typically, when you start a patient up, an adult patient, you're going to initiate flow at somewhere between 30 to 40 liters per minute. And you can titrate up based on their respiratory rate, dyspnea, and comfort. Okay? You also can independently control with this blender the oxygen concentration that you're delivering. So I can deliver anywhere from 21%, which is room air, all the way to 100%. And you're going to titrate your oxygen concentration based on where you want to maintain their O2 sats. Okay? So theoretically, I could put a patient on this therapy at 21% oxygen concentration, room air, and just give them the benefit of the humidity and the flow support. This is a heated wire circuit. If you could see inside of it, you would see a spiraled circuit, or I'm sorry, a spiral wire. And the purpose of that is that we're creating water vapor, molecules of water vapor. As the gas passes down the circuit, we're trying to keep it above its dew point. If it falls below that dew point, it's going to create condensation. So the water is going to go from the vapor state into its liquid state. Okay? When water is in its liquid state, it can actually carry pathogens up into the airway. So we prefer to keep it in its vapor state because a molecule of vapor is thousands of times smaller than the smallest known pathogen. Okay? Once in a while, you'll see that there might be a little bit of condensate in the tubing that's formed. It's okay to go ahead and drain that back down into the chamber. In fact, that's why we recommend keeping the heater base below the level of the patient so that you're always maintaining a downward slope away. Okay? This is the cannula. It's very lightweight and flexible. It comes in 3 sizes, small, medium, and large. And we're talking mainly about the size of the prong. This is a large. It's very big. Most patients will not be a large. The rule of thumb when a patient is fit with a cannula is that we want to fill about 50% of their nair diameter. Okay? The more nair you fill with the prong, the more pressure you generate. So what we want to really stay away from is we don't want to create a seal or a closed system. It's designed to be an open system with some leak coming out around that prong. Okay? Conversely, if you have a really large nair and you're using too small of a size, the patient is actually going to lose out on some of the benefits of it. There's a lanyard necklace that has a breakaway to it. Go ahead and put that on your patient. And then you can tighten it up. You want it, the purpose of the lanyard necklace is to keep the weight of the circuit from pulling the cannula out of your nose. So what you want to see, this will go up, behind their head, above their ear. But what you want to see is some slack, like a little bit of an S shape here, so that your patient has freedom to move around. If it's not tightened up, you can see how it will pull out of here. Okay? On rare occasion, you might have a patient that doesn't want this around their neck. You can go ahead and try to pin it to their gown or their bedding, depending on if they're laying in bed. A neat thing about OptiFlow as a therapy is that while on it, your patients will be able to eat and drink and talk or sleep more comfortably, things that are difficult, if not impossible, with a mask oxygen. The other thing that research has shown is that OptiFlow can reduce your utilization of non-invasive ventilation. And the reason for that is because there's a certain percentage of patients that are in hypoxemic respiratory failure that are being put on BiPAP. And now we have the capabilities of a device that can deliver up to 60 liters per minute of flow, up to 100% O2, and we can meet the needs of a lot of those patients. They no longer have to be on BiPAP. But I want to make it clear, if they're in hypercapnic respiratory failure and they actually need to be ventilated, this will not work for them. Okay?
Makes sense.
Any questions?
So if I am titrating, you would prefer to titrate the oxygen percentage first?
You'll titrate both. They're independent of one another. So again, you're going to titrate your oxygen concentration to sats, and you're going to titrate your flow in liters per minute to part of that is subjective, but it's comfort and respiratory rate and dyspnea. Now, when you're weaning a patient, you actually will want to wean oxygen concentration, typically wean that before flow. And then now another difference with this would be that when you're charting, you wouldn't only just chart liters per minute, you would also chart oxygen concentration.
You guys do that when you do vitals and stuff, but we do check that also. The one thing we haven't talked about with the other group, maybe we can a little bit here, is because it always happens on night, so when there's fewer RTs around, is maybe some troubleshooting. One of the things would be just the water bag itself running empty. The heater's going to alarm. You notice when we unplug, if one of these is not, it's a pretty good indication that maybe one of your air outlets. I just unplugged the air, this is the oxygen, so that's a pretty good idea that, you know, your gas lines are not connected. Anything else you wanna add?
One more thing, just going back to the temperature, so if you were to remove this from a patient and then you wanted to go put it back on them later, you don't want to initiate the flow and not let it warm up at least a little bit, because if it's coming in cold and dry, it's gonna feel like pins and needles, and most patients are gonna tell you rather immediately that they do not like the therapy. So at a minimum, you'll wanna let this warm up to about 30 or 31 degrees, and then put it on them, and then it will gradually continue to warm up to 37. That would be ideal.
Is this something people can do at home?
We do have another device that allows patients to do this at home. It's actually relatively new, and it's not commonplace yet because there's no reimbursement code for it in the home care. So
And
yes, you
there
could
would
theoretically.
be a
Yes.
way of getting that much oxygen to their house?
No. It actually, the specs on that device, it can deliver from 15 to 45 liters per minute.